Booster 18 just arrived at the test stand. Ship 39 stands fully stacked. Both are Block 3, SpaceX's most advanced Starship hardware yet, targeting a January launch. But while Flight 12 preparations accelerate, something's breaking down behind the scenes. A Raptor V3 exploded during startup at McGregor. Leaked documents show SpaceX preparing to delay Artemis 3 until 2028. And NASA just opened the lander contract to Blue Origin. What's really going on with SpaceX's moon program? Let's start with what's actually happening at Starbase. Ship 39 stands fully stacked inside Mega Bay 2, waiting for its aft flaps. Technicians are racing through internal work, hydraulic lines, pneumatic systems, electrical routing, avionics integration. Heat shield tiles are going on simultaneously. Once finished, Ship 39 moves to Massey's for cryo testing. Booster 18 took a different path. Thursday morning, it rolled to Massey's already fully stacked. All 33 Raptor engines mounted, plumbing and electrical systems integrated. Now engineers will load it with thousands of tons of liquid methane and oxygen, chilling the tanks to minus 297 degrees Fahrenheit. They're testing weld strength, structural integrity, tank performance under full cryo load. Block 3 isn't just an incremental upgrade. Booster 18 carries modifications that make Block 2 look like a prototype. Reinforced structures, upgraded avionics, better thrust vector control, enhanced recovery systems. SpaceX is targeting January for Flight 12, which means all testing needs to wrap by December's end. Aggressive timeline, but progress suggests they're hitting their milestones. But here's where things get complicated. Politico obtained a leaked document showing SpaceX is preparing to request additional time from NASA for the Starship human landing system, the vehicle that's supposed to put astronauts on the moon for Artemis 3. The architecture was always complex. Multiple tanker starships transfer propellant to an orbital depot. The depot fuels the HLS lunar lander. NASA launches 4 astronauts on SLS and Orion. Orion docks with HLS in lunar orbit. 2 astronauts transfer to the lander, descend to the surface, spend about a week exploring, then return. Simple on paper, extraordinarily difficult in execution. The leaked schedule reveals what NASA hasn't publicly acknowledged. SpaceX now targets June 2026 for propellant transfer, not early 2026. June 2027 for the uncrewed lunar landing. September 2028 for the earliest crewed attempt. That's more than a year beyond NASA's current target. These dates haven't been formally communicated. SpaceX plans to submit an integrated master schedule in December, which will likely force NASA to completely revise the Artemis timeline. And NASA leadership already has serious concerns. Former Administrator Jim Bridenstine said large-scale cryogenic propellant transfer carries significant risk with zero flight heritage. His words, "This is an architecture that no NASA administrator that I'm aware of would have selected had they had the choice." Acting Administrator Sean Duffy went further. He publicly stated SpaceX is behind schedule and announced plans to reopen the lander contract to Blue Origin and other competitors. His message was clear. SpaceX had the contract, but they're not delivering on time. SpaceX responded last month, claiming they've completed 49 major HLS milestones. They acknowledged concerns and said they're evaluating a simplified mission architecture, but haven't revealed what that actually looks like. The gap between NASA's public targets and SpaceX's internal projections keeps widening. While the HLS schedule faces turbulence, SpaceX is hammering Raptor development. Down at McGregor, a Raptor V3 recently experienced what engineers call an anomaly during startup. Stand explosions aren't rare, but this failure was different. Most Raptor failures happen late in tests when engineers deliberately push beyond design limits. This explosion happened before the engine even reached stable ignition. Sparks erupted from the test stand. Thick smoke engulfed the entire bay. SpaceX hasn't commented, but two scenarios make sense. First, genuine startup failure. Methane full-flow staged combustion engines are brutally sensitive during ignition. Minor timing errors or mixture ratio problems can trigger a hard start, an internal explosion in the preburner or main chamber. Preburner ignition faults, incorrect mixture ratios, delayed ignition, pressure spikes, valve sequencing errors, any can destroy an engine in milliseconds. Second, intentional test. SpaceX routinely pushes subsystems beyond thermal, pressure, and mechanical limits to gather boundary data. If this test stressed the startup sequence, engineers might have been studying how turbopumps, injectors, chambers, and nozzles respond during aggressive transients. That data becomes especially valuable for Raptor V3, tuned for higher thrust, higher chamber pressure, faster throttle transitions. Whether failure or intentional test, a startup phase anomaly shows how aggressively SpaceX is pushing Raptor V3's performance envelope. Back at Starbase, Pad 1 is being systematically demolished. Crews cut apart and removed the orbital launch mount's top ring this week, separating all 6 legs. Then legs started coming down one at a time, pushed over by excavators. 4 are down, 2 remain. The launch tower gets major upgrades. Mechazilla catch arms are being shortened to match Pad 2's compact design, improved rigidity, reduced bending loads, increased precision. During catch operations, the original Drawworks hoist system was removed, replaced with higher capacity equipment for heavier Block 3 vehicles. Ground support systems are being modernized. The berm wall between tank farm and launch pad was removed for a reinforced blast wall. Crews pulled out old pumps, heat exchangers, propellant lines, auxiliary tanks. The entire tank farm is being rebuilt to match Pad 2's layout. Once complete, Pad 1 will mirror Pad 2's robust configuration, enabling rapid cadence Block 3 operations. While Pad 1 comes down, Pad 2 approaches readiness. Teams completed extension and retraction tests on the dual booster quick disconnect system. Final protective hoods around each BQD were just installed. Last week, a test fixture nicknamed ibuprofen load-tested all 20 hold-down clamps, verifying capacity, operation, and failure modes before placing a fueled booster on the mount. The ship quick disconnect arm arrived at the launch site Wednesday. Most internal plumbing and electrical systems are pre-installed. Once installed and integrated, Pad 2 will be ready to support Flight 12's Block 3 campaign. Now, while SpaceX deals with Artemis delays and Raptor explosions, something unexpected happened 250 miles above Earth. China's Shenzhou 20 crew just returned home. But not in their own spacecraft. 3 astronauts launched to Tiangong on April 24th for a 6-month rotation. They conducted research, completed 4 spacewalks over 27 hours. Everything proceeded normally until early November, when their replacements arrived. After the change of command ceremony, the Shenzhou 20 crew prepared for their November 5th return. But ground control postponed after detecting evidence the re-entry capsule may have been struck by orbital debris. Engineers activated contingencies, impact simulations, structural reviews, wind tunnel analyses. They used Tiangong's robotic arm to inspect the capsule. After days of assessment, they confirmed a small crack in the window, consistent with debris strike. They ruled the vehicle unsafe. Mission controllers revised the plan. The Shenzhou 20 crew would return aboard the Shenzhou 21 capsule instead. On November 14th, it undocked, executed re-entry, and landed safely in Inner Mongolia. All three astronauts emerged in excellent condition after 208 days. But this created a problem. Shenzhou 21 astronauts remain aboard Tiangong without a return vehicle, a temporary lifeboat gap. China announced Shenzhou 22 will launch uncrewed by November 25th, giving the crew a way home around April 2026. The damaged Shenzhou 20 remains docked for analysis, structurally stable but no longer certified for crewed descent. This incident highlights growing debris dangers in low Earth orbit. Both ISS and Tiangong routinely dodge debris, but some risks remain impossible to eliminate.